To blast anything free from Earth's strong gravity requires immense force, far more power than it takes to launch a lunar meteorite off the surface of the Moon. For example, a space shuttle uses 15 million horsepower to escape from Earth's gravity. A lunar module needs just 6,300 horsepower to lift off from the Moon. But just how big an impact would it take to blast debris off the Earth? Award-winning astrophysicist Guillermo Gonzalez from Iowa State University has worked out the answer to this question.
The crater in northern Arizona, meteor crater, even that, which is really big when you go right up to it, wasn't large enough to catapult any significant amount of material beyond Earth's atmosphere. But when you're talking about, say, the crater that killed the dinosaurs in Mexico, now that one was probably big enough to start launching some at least small amount of material beyond the Earth and have some of it land on the Moon.
Impacts on Earth during the lunar cataclysm were far bigger than the dinosaur extinction event. They had so much power that they punched holes in the Earth's atmosphere. Rocks and debris thrown skywards escaped through these holes, and once in space, some of the debris was vacuumed up by the Moon, orbiting just 140,000 kilometers away.
And it eventually makes its way to the Moon, where it lands. And then when it lands on the Moon, of course, it could be further broken up into smaller pieces depending on how fast it hits the surface.
Since landing on the lunar surface, they've remained perfectly preserved in the vacuum of space.
The early Earth, unfortunately, erased its early history, but it left a record of it, at least a partial record of itself, on the Moon. And if we can find some fossils or at least remnants of early life in these Earth rocks on the Moon, that can help us answer these difficult questions about the origin of life.
Gonzalez believes that close to 20,000 kilograms of Earth rock could be spread over every 100 square kilometers of the Moon's surface.
It's the only place in the solar system that we can go to learn about the origin of life, because once the Earth rocks get to the Moon, they're preserved there in a pristine form. There's no water cycle on the Moon, there's no more active geology, and they get buried relatively quickly from the material from other impact on the Moon. And so they're preserved from the solar wind and other things as well.
So far, no Earth rocks have been found on the Moon. Gonzalez will have to wait until the next Moon mission and hope that these priceless rocks may then be discovered. The first half-billion years of the Moon's journey from Earth was a violent one. Over the next billion years, the Moon continued its escape from Earth and out into space. And its passage changed the face of our planet beyond all recognition. The power of its gravity created tides hundreds of meters high, which stirred up the oceans of the Earth. And this created the conditions for complex chemical compounds to form. The Moon was aiding the creation of life on Earth. "3 billion years ago, the Moon was still escaping from the Earth and orbiting around 320,000 kilometers away. The effect of its gravity was now weaker, but it still had the power to radically change our planet. The Earth had water and oceans, and the Moon was stirring things up. It was too far away to have a dramatic effect on the rocks of the Earth, but the Moon did affect the oceans. As the Moon passed overhead, its gravity created tides in the water. But these weren't like the tides of today. They were hundreds of meters high. Astronomer Neil Commins has studied how the early Moon affected the tides.
When the moon first formed, the tides were something like 1,000 times higher than they are today. They would have gone inland as a wall of water, 10,000 feet high as a huge mountain. They probably would have covered hundreds of miles. And then they would come back, scouring the land, taking debris from the surface of the Earth into the oceans.
The material sucked into the seas contained minerals and nutrients, and the tides created by the moon churned these into the most crucial cocktail in the history of the Earth, the primordial soup. Different combinations of minerals were bound together and torn apart, and it was in this violent melting pot that the right combination of minerals was forged into life. Cummins believes that the spark of life might never have occurred had the moon not churned up the primordial soup.
The moon created those tremendously high tides back when it first formed that allowed the oceans to fill with minerals, that allowed life to evolve, that allowed us to be here.
The tides may even have helped the first DNA to evolve. Some scientists believe that the changes in chemical concentrations when the tides went in and out caused the DNA to split and replicate. And the enormous moon-induced tides had a further vital role to play in the history of the Earth. They helped the whole atmosphere of the planet to calm down and become a more hospitable place in which more complex life could evolve. 3 billion years ago, the Earth was a very different place. The impact that had created the moon also set the Earth spinning faster. It spun so much faster than it does now that a day lasted just 6 hours. And this high-speed spin had devastating effects right around the Earth. The rotation of our planet is one of the most influential factors determining global climate. The spin of the planet creates winds and vortices in the atmosphere, and the faster the spin, the faster and more violent the winds. Billions of years ago, when our planet rotated 4 times faster, the atmosphere whipped over the land.
When a hurricane occurs today, 100-mile-an-hour winds, trees are blown over, houses lose their roofs, tremendous amount of flooding. But in a day or two, it's gone. Things settle back to normal, people get on with their lives. Imagine if we lived on a world in which those kinds of winds were continuous.
This was the climate of our fast-spinning early Earth, a place with constant hurricane-force winds and giant 3,000-meter tides. It was far too hostile a climate for life to evolve into more complex forms. But the devastating tides created by the moon began to pacify this hellish climate. The tides affected the speed of rotation of our planet, eventually lengthening a day from 6 to 24 hours. As the Earth's rotation slowed, the atmosphere ceased to whip around the globe. Hurricane-strength winds were no longer the norm, and more complex life forms began to evolve in the relative peace and calm of our planet.
I really think that we owe the moon our existence today. Without it, the world would have evolved differently, and as a result, we would have evolved differently. We would not be the creatures we are.
The power of the nearby moon has dramatically reshaped our planet. Over the last 3 billion years, the moon has continued its journey out into space. Its influence has waned, but it hasn't disappeared. Some scientists believe it causes earthquakes and volcanic eruptions, while many laymen still believe that the full moon can affect human behavior in some bizarre and inexplicable ways. Today, the moon orbits Earth 400,000 kilometers away, 15 times further from Earth than when it first formed. It now appears as a distant and mystical object in the sky, and its gravitational pull is far weaker than it used to be. It's now so small that it exerts the same upward pull as a pea held about half a meter above your head. But some people believe that even this weak power can affect human behavior. The moon's 29-day orbit around the Earth is called the lunar cycle. And during the lunar cycle, the appearance of the moon changes because it's constantly moving relative to the sun and Earth.